All right, we are switching gears a little bit today so that we can talk about scatter plots and lines of fit. Scatter plots are something that you probably have seen in other classes. Before this math class, you might have seen them in science classes. Standardized tests, you'll usually see them. Dominic?
Or even in Mr. Placer's class.
Yep, other math classes. It's a possibility. We got our objective down. So our objective is to interpret scatter plots, identify correlations between data sets, and make predictions using data. So our three big goals for today. A scatter plot is a graph that shows the relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. Scatter plots can be used to show trend data. So we'll see some examples of that, but in general, scatter plots are usually applied to some sort of real life situation. That's why they can be seen a lot of times in biology and chemistry classes. We're relating two different variables to each other. So a lot of the times with these scatter plots, as the name might suggest, the points are not necessarily all going to be in a straight line. They're going to be scattered about the plot, scatter plot. So it might not always look nice, neat, and organized. All right, here we have an example of a scatter plot that's already been made for us. It shows the amount X in grams of sugar and the number Y of calories in 10 different smoothies. So there are 10 different points on our graph. Okay, so first thing, being able to interpret this, our sugar is shown on the x-axis. Our calories are shown on the y-axis. So each of these points represents a smoothie, and it shows how many calories are in it and how much sugar is in it. Jasha?
Is the first one 270?
I don't know. I haven't even read the question yet. Another thing to notice about our scatter plot are down here by the zeros. This is something you might have seen in a science class where they do that little zigzag to show that they're kind of skipping ahead. So they didn't count all the way from 0 up to 46. They just put that little zigzag to say they're going to start at 46 instead. Same thing with the y-axis. They wanted to start it at 240. If they'd started it truly at 0 and counted up, then this graph would have been way too big to fit on your paper or on the screen. All right, so question A, how many calories are in the smoothie that contains 56 grams of sugar? So, some of you may have already done this or tried to do this. If we figure out where about 56 is going to be on our sugar line, what numbers would it be between?
54 and 58.
Good, it would be between 54 and 58. So if we kind of draw a line, that's a really thick line, but if we kind of sketch in a little line that goes up there, maybe even just a little dashed line, we could see that we're only going to hit 1 point if we do that. And how many calories are in that smoothie? 270. So we then follow that line out to the calories.
Do you have to put those little line marks on?
Nope, you do not have to draw the little line marks. I'm just trying to show you where you might move your pencil to be able to figure that out. Are we all okay with 270 calories for letter A? Okay. Letter B. How many grams of sugar are in a smoothie that contains 320 calories?
70.
Okay, so this time we're going on the calories up to 320. We trace across, we find this point. And yes, I agree with those of you that have said that that means it has 70 calories. Questions about A and B? Being able to read our scatter plot? All right, letter C is not meant to be challenging, but for some people it seems to be. Letter C wants to know what tends to happen to the number of calories as the number of sugar increases. So in general, what's happening to calories as sugar goes up? It's doing what? Increasing. So as our sugar content keeps going up, in general, our calories keep going up. That might not be the case every single time. Okay, so sometimes our calories are lower, but the sugar is lower, but the calories are higher than some other points. But in general, as sugar increases, calories increase. So you will be asked at times to interpret the relationship that is shown on a scatter plot. Usually it starts off by saying, as this increases, then this either increases or decreases. Or as this decreases, then the other one increases or decreases. Questions about example 1? Okay, let's move on. Correlation, that was our second big idea in our objectives. Correlation is the relationship between data sets. We can use scatter plots to describe the correlation between data. So for the first scatter plot there, as x increases, y increases. And that looks similar, has a similar shape to the first problem that we just did. As the sugar increased, so did the calories. Same kind of idea here. Yes, we should be writing down that as x increases, y increases. That's a positive correlation. The one in the middle, your negative correlation, shows that as x increases, y decreases. And for the last one where there's no correlation, the points show no pattern. So they're really just scattered all over the place. We can't see a trend in the data. Okay, so the other thing I want you to notice before we move on from this slide is that, and we might talk about this again when we talk about line of fit, but in general, if I were to try to draw a line that went in the middle of all these points, that line has a positive slope. It's going uphill. Positive slope. Positive correlation. Kind of the same idea. Same thing here for the negative correlation. If I were to put a line that was in between those points, it has a negative slope to it. So that might help you remember the difference between positive and negative correlation if you think about the slope of the line that would go through them. Of course, no correlation means there's no good way to put a line in the middle of all those points. It'd have to be way too zigzagged to go through them. Questions about correlation before we look at example 2? Okay. On example 2, tell whether the data shows a positive, negative, or zero or no correlation. Okay, so letter A, age and vehicles owned. We had 1 vote for 0. Any other votes? Annabelle? 0. Dominic?
I vote for 0.
Vote for 0. Any votes for anything else? Okay, I would agree. There's no great way of putting a line through the data set. They're a little too far apart from each other. So I agree that on this one we would see 0 or no correlation. All right, our second graph shows temperature and coat sales at a store. What do we think? Negative. Anybody think anything different? I would agree with a negative correlation, which should make sense. As temperature goes up, coat sales go down. So yes, that would be a negative correlation. Questions, concerns? We ready to make a scatter plot? Yes, no, maybe so. All right, make a scatter plot of the data. Tell whether the data shows a positive, a negative, or no correlation. So when we do this, they already set up what our axes should be. So our x-axis should be labeled with age of a car. So I would actually write that by that axis. Age of car. And then our y-axis, oh, mine got covered up there a little bit. I'll move it down below. Age of car. It's a little better. Then our y-axis is the value of that car in thousands of dollars. So our y-axis is our value. Now we kind of have to decide what our scale is going to go by. I would say that for our age of cars on our x-axis, we're just counting from 1 to 8. So I think we could fit that on this graph. So we can start at 0 and just count up to 8. Okay, for our y-axis, we need to include 7 up to at least 24. So I would say we'd probably be safe if we counted by, let's say, 3s, maybe 2s. 1, 2, 3, 4, and 5. Let's count by 2s to spread it out just a little bit. 2, 4, 6. 8, 10, 12. So that's going to take us all the way up to the very top of our graph. 14, 18, 20, 22, 24. All the way up to the top. Questions about labeling our scale? That should always be your first step, because if you don't have a scale on your grids, then there's no way that you're going to be able to plot your points. All right, take a couple minutes and plot your points. So remember 1, 24 would mean I go over 1 on the y-axis, then up to 24 and put a point. Plotting points is something you should be able to do. Again, if these numbers like 21 and 19 don't lie on one of our lines, it's going to have to go in between. So get all of your points plotted and then think about what kind of correlation you see. All right, if we keep plotting these, 2, 21 is up here. 319, 418, 515, 6 is at 12, 7 is at 8. Now we're starting to drop off pretty fast, and 8 is at 7. All right, I would agree that in general, there would be a line that could go through the middle of this with a negative slope to it. So yes, this would have a negative correlation, which means as age increases, what happens? Not cost. The value decreases. So if, I know this question doesn't ask it, but if I were to ask you to guess how much the car is valued at when it's 10 years old, what do you think would be a reasonable guess? Two? Okay, that could be reasonable. 3? That seems reasonable. Would we guess that the car is worth $15,000 when it's 10 years old? Why not? Because that keeps decreasing. So we expect that at 10 years it should definitely be less than how much? At least less than it was at 8 years, right? If it was $7,000 at 8 years, we would expect it to absolutely be lower than that. So even if we don't know something for sure, we can kind of make an educated guess about a possibility based on this data. Questions, concerns before we talk about line of best fit? All right. Line of best fit is something that you've been seeing me throughout these notes draw in on the scatter plots. All right. The line of best fit, I've been kind of drawing some examples of those in when we were talking about correlation. It's drawn on a scatter plot. It's close to most of the data points. So to use a line of best fit, you're going to make a scatter plot of the data. We just practiced doing that. Decide whether the data can be modeled by a line, which means it needs to have positive or negative correlation. It cannot have no correlation, otherwise there's going to be no line. Draw a line that appears to fit the data closely. So you've seen me do it a couple times, and each time I wasn't super precise about it. It's not like it had to start at one point and go to another one. I just drew it in so that it was in between or around as many points as possible. Write the equation of the line. The points do not have to represent actual data pairs, but they must be on the line of best fit. That's going to be the tricky part for most people, is actually finding points that truly are on the line, not points from the data they gave you. And step 4 of this little chart is going to be very similar to those 4 steps that you practiced yesterday, that you did the day before, that you did over Thanksgiving break. Okay, writing the equation of the line is going to go back to those same 4 steps of find your slope, find a point and your slope to put in point slope form, distribute your slope, get y alone. That's all included in this step 4. So there's a lot that goes into this. Do we have questions before we give it a try? Okay. Let's move on to example 4. It's our last example, but it is a little bit of a long one. The table shows weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. Interpret the slope and y-intercept of the line of fit. So there's a lot that they want us to do, but if we look back on our last page, the first step is to make a step 1 said make a scatter plot. That's our first step. So even though there's a lot that they're asking us to do, we definitely know how to get started. We need to make ourselves a scatter plot. Okay, so we need to decide what to count by on our axes. So on our x-axis, what variable is going there? 1, 2, 3, 4. That represents our weeks. So down here we're going to have our weeks. And again, yes, we could probably just count them out. 5, 6, 7, 8. Okay, you've got a little bit more room to work with than I do, which is nice. On the y-axis, what are we putting? Sales. So we definitely need to include what range of values? From what to what?
Least to greatest.
We'll go from least to greatest, but what numbers definitely have to be on there, Liam? What? 1 to 20 would be good. We definitely need 5 to 19. So, yes, I would agree 1 to 20 would be a good way to go about it. So, I think we could probably count by 2s again, right? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, that would be our sales. Probably will have a negative correlation, yes. So go ahead and get your points plotted. I'll work on plotting mine. We'll make sure they all match up, and then we'll go from there. Get all our points plotted? Okay, yes, it should have a negative correlation. So as the weeks increased, the sales decreased. So we can use a linear model. So that from the last page or last slide, that was number 2, decide if it can be represented or modeled by a line. So yes, there's a negative correlation here. We can use a line. So step 3 from that last little slide said to draw a line that appears to fit the data closely. There should be points above and below the line. So we're trying to just put a line in that looks like it goes around as many of the points as we can. Maybe some of the points are on the line, above the line, below the line. Your line might look a little bit different than mine. It should look close. But notice how some of my points are a little bit below, some of my points are a little above. A couple of my points appear to be pretty close to my line. One of the hard parts about this is that sometimes there can be more than one correct answer. Did we all draw a line in that fits closely? Okay, when you do draw your line of best fit, make sure you're drawing a straight line. It's okay that the line doesn't touch all the points. It's not supposed to. So you should not be drawing connect the dots. You should just draw a straight line through it. All right. Next, we are going to write the equation of the line. The points do not have to actually represent data pairs. They must be on the line of best fit. So we want points, in my case, that are on the purple line. They don't necessarily have to be red points from the data. So I'm going to be picking points to use that are at the crosshairs or the grid lines. So I'll try to highlight them in yellow. This seems like a good place to use for me because that crosses at a grid line. So I'm not using that red point. I'm going to use the point at that grid line, which is going to be 412. Now, when you do these on your own, you might choose different points than I would. But for me, the point 412 appears to be on my best fit line. I need to choose one other point to use. So, another point that it appears to hit nicely is up here a little bit further at 216. So I picked points that looked like they crossed the grid lines nicely. Do we have questions about how or why I picked those points? Now, if your line of best fit didn't hit those points quite as nicely, you can either adjust it, you could try using different points, but your equation of your line will probably come out a little bit different. I know this process is long. We're not done with it yet. Do we have any questions so far? Are y'all still with me? Because when I give you an assignment to do this tomorrow in class, you gotta be able to know how to do it. From here on out, until we get our equation of our line, this is like what we've been doing for what seems like forever, but at least a week. We have 2 points. We want to write an equation. So the first thing we need to do is find the slope. Find the slope. If you want, you could use your graph to count rise over run, or we've identified these points. We could use our slope formula. What would go in the numerator? 16 minus 12 over 2 minus 4. 16 minus 12 is 4. Negative 2. Our slope is negative 2. So we found our slope. Now we have to pick a point to use. Which point do you want to use? 412. Pick a point and put it in a point slope form. So it would look like y minus 12 equals, good, negative 2 parentheses x minus 4. That was step 2 from those 4 steps that we've been reviewing over and over and over again. The third step is to distribute the negative 2. So we have y minus 12 equals what? Plus 8, good. Negative 2x plus 8. Last step is to get y alone. So we would add 12 on both sides. So we end up with y equals, good, negative 2x plus 20. Questions about how we came up with that equation? Okay. The very end of that problem said interpret the slope and y-intercept of the line. So, when we interpret the slope, our slope was negative 2. We could write it as negative 2 over what? 1. Now, let's think back to when we found slope. When we found slope, what variable or which letter goes on top? Which variable goes on top when we find slope?
The y.
The y's. So this would represent our Y, which our Y's in this case were sales in millions of dollars. So this is our sales in millions. And what did our X represent on the bottom? Weeks. So when we interpret this, it's saying for each week that passes, what's happening to the sales? They decrease by how much? Sales decrease. So we knew it decreased because of the negative by, Dominic? 2 million. For each week, sales decrease by $2 million. That's an interpretation of our slope. Okay, we also are asked to interpret the y-intercept. So I'll do that up here at the top. I'm running out of space. What is the y-intercept in this case? 20, but as a ordered pair, what, comma 20? Careful for the y-intercept, x is always 0, so 0, comma 20. So if this is our y-intercept, how many weeks have passed since the release? At this point? How many weeks? Somebody might be saying it. Oh, no, not 20. How many?
9.
Not 9. Well, if it's not 20, what's the only number here, guys? 0. 0 weeks have passed. It just got released. It just happened. So at its release, or on the release date, no time had passed yet. How much money did they make from it? What were the sales? Remember, this is X comma Y. X was our weeks. 20 million. So at release date, sales were 20 million. Questions about example 4? Are we sure? Okay.